Welcome back, everyone. Today, we're going deep on someone who might sound familiar even if you're not a total physics nerd. Werner Heisenberg.
Ah, yes, Heisenberg. His work, it always feels so complicated. But it really affects all of us every day.
Right. And we're going to try to make sense of it all. Oh, and his whole life story, too. Using this essay by Hugo Schneeppert, it's called Werner Heisenberg, Unschärferelation on Quantum Technology.
Okay.
So, ready to dive in?
Yeah. Always cool to see how these big ideas in science end up in the tech we use.
Okay. So, first, who was Werner Heisenberg? Schneeppert makes him sound like a real prodigy.
He was born in Germany, 1901, grew up in a super academic family. His dad was a professor, so not a surprise. He was amazing at math and physics really young. Schneeppert even says he was already into, Planck and Einstein as a kid.
Wow, like he was destined to shake up physics. But even geniuses need some help. Schneeppert says that too. He had some serious mentors, right?
Oh yeah, big names. Max Born, Niels Bohr. The stars of early quantum physics, they really shaped how Heisenberg thought. Helped him figure out the atom.
So talent AD, amazing teachers. What did he actually do that made him so famous?
Two huge things for quantum physics. First, matrix mechanics in 1925. Then 1927, the uncertainty principle.
Okay, those are the things you always hear about.
Yeah.
But to be honest, they sound kind of scary. Let's start with matrix mechanics. What was so different about it?
It was a whole new way to describe how particles act, at the subatomic level.
Yeah.
Before, physicists tried to use the same rules for big stuff, like planets or billiard balls, and apply them to tiny atoms. Didn't work.
So it's not just that atoms are small, it's that they have different rules.
Exactly. Heisenberg, and born in Jordan too, realized they needed totally new math. That's where matrices come in. They're like grids of numbers that show the connections between a particle's properties. The interesting part is, matrix mechanics doesn't try to say exactly where a particle is at any moment. Yeah. It's more about the chance of finding it somewhere.
So instead of like a clear path, it's more like a blurry cloud of possibilities. That must have been a big deal back then.
Huge. Schneeppert even says people resisted matrix mechanics at first. It was very abstract, changed how they thought about the universe. But in the end, it was super powerful for understanding the quantum world.
It sounds like Heisenberg wasn't afraid to challenge everyone.
Yeah.
I am curious about his other big idea, though, the uncertainty principle. It's become kind of a pop culture thing. But what's the real story with the uncertainty principle?
It's more than just saying, hey, life is unpredictable. It's a real law of nature, basically, it says. You can't know both the position and the momentum of a particle perfectly at the same time. The more you know about one, the less you can know about the other. And this isn't about our tools being bad, it's baked into reality itself.
So it's not that we just haven't measured well enough. There's a fundamental fuzziness to the quantum world.
Exactly. Hugo Schneeppert really emphasizes this. It was a huge change from the classical physics idea that everything was predictable. Imagine trying to tell someone used to a perfect clockwork universe that at the smallest level, things are just uncertain. It's like saying, hey, that clock you like, it doesn't really tell time. It just gives you a bunch of possibilities.
That's a great way to put it. Must have blown some minds back then. But for us non-physicists, does this uncertainty really matter in our lives?
That's where it gets interesting. Schneeppert explains, the uncertainty principle isn't just a theory. It's directly connected to technology, especially stuff like quantum cryptography and quantum metrology.
Hold on. This crazy uncertainty principle is in the tech we use every day.
Yep. And not just in a vague way. Heisenberg's work is the basis for some of the most exciting new tech being developed.
Okay. I'm officially hooked. Let's start with quantum cryptography. I've heard about unbreakable codes and spy-proof stuff. But give me the whole story.
All right. Imagine a world where everything online is totally secure. Your banking, government secrets, even personal messages. No one can snoop. That's the promise of quantum cryptography. And it's all thanks to Heisenberg and his uncertainty.
Wait, how does uncertainty equal security?
It's pretty clever. If someone tries to eavesdrop on a quantum communication, they mess things up just by listening. Thanks to the uncertainty principle, it's like a built-in alarm, telling the sender and receiver someone's trying to listen in.
So it's like a message that self-destructs. If you try to intercept it, the information gets messed up.
Yeah.
And everyone knows.
Exactly. All because of that fundamental fuzziness Heisenberg discovered. Eavesdropping becomes super noisy in the quantum world. The old ways of encryption use math that you could maybe crack with enough computer power. But quantum cryptography, the security comes from the laws of physics themselves.
That's amazing. It's like having a security system designed by the universe. Schneeppert also mentions this quantum metrology. What is that?
Now we're talking insane precision. Quantum metrology is about using quantum mechanics to measure things incredibly accurately. We're talking clocks measuring time to billionths of a second, sensors picking up tiny changes in gravity, and microscopes that can look right into the heart of matter.
And the uncertainty principle, which is all about fuzziness, plays a role in this. How?
It's kind of weird. The uncertainty principle does set a limit on how precisely we can measure certain things. But the brilliance of quantum metrology is that it works within those limits. It uses other quantum stuff to get amazing precision. It's like turning a weakness into a strength.
So scientists are using Heisenberg's principle, which tells us there are limits, to make measurements more precise than ever.
Exactly. For example, atomic clocks. The uncertainty principle says the more precisely you measure an atom's energy, the less you know about its frequency, and vice versa. But scientists have learned to control atoms, to squeeze that uncertainty, and get super accurate timekeeping.
Wow. That's incredible. Okay, so we've got Heisenberg's early life, his revolutionary work in quantum mechanics, and we even started talking about how his ideas affect technology. I'm ready to go deeper. What about the philosophical side of his work? Schneppet mentions that too, right?
Yeah. Can't talk quantum mechanics without getting philosophical. Heisenberg's work, especially with Niels Bohr, led to the Copenhagen interpretation of quantum mechanics. That really shook things up.
Okay, deep breath.
Yeah.
And let's dive into that philosophical pool, the Copenhagen interpretation.
Yeah.
What's the basic idea?
Basically, it says that in the quantum world, things don't have fixed properties until you measure them. They exist as a range of possibilities, represented by something called a wave function. When we measure it, that wave function collapses, and the property takes on a definite value.
So, until we look, the quantum world is just blurry potential, and we force it to choose a state by observing.
That's wild. Totally. And it went against the classical idea of a reality that's objective, independent of us observing it. The Copenhagen interpretation puts the observer right in the middle, suggesting that we're not just watching the universe, but actually helping to shape it at the quantum level. Schneppet says this sparked a lot of debate, and physicists and philosophers are still talking about it.
Mind-bending for sure. So Heisenberg didn't just discover new laws. He also changed how we think about reality itself.
Yeah. And that's just the start of his impact. We've only scratched the surface.
Okay. Well, I'm hooked. Bring on part 2.
Let's do it. Back again for more Heisenberg.
Still thinking about our last chat. It's crazy how his work, which seems so out there, is now the basis for all this groundbreaking tech.
Yeah, it shows how fundamental research can have surprising consequences. And with Heisenberg, it's not just the discoveries themselves. His legacy goes way beyond that, into philosophy of science, too.
Right. We started talking about the Copenhagen interpretation and how it changed how we understand reality. It's a lot to take in.
It is. Remember, Copenhagen interpretation, mostly Heisenberg and Niels Bohr's ideas, saying that at the quantum level, reality isn't fixed. It's a bunch of possibilities until you measure it.
So instead of a universe like a clock you can predict, it's more like a roulette wheel, where the outcome is only decided when the ball stops.
Perfect analogy. And that's so different from the classical physics view, where everything was supposed to be deterministic. It brought in this idea of uncertainty and probability into how we understand the universe. It was controversial at first, but the Copenhagen interpretation eventually became widely accepted. It's still a foundation of quantum mechanics.
It's amazing how Heisenberg forced scientists to realize that our everyday way of thinking doesn't always work.
Totally. Heisenberg pushed scientists to be more pragmatic, focused on results. Instead of looking for absolute certainty in a universe that's fundamentally uncertain, the focus shifted to making theories that could predict what we see in experiments, even if those theories didn't quite match our normal experience.
So instead of asking what is the universe really like, they started asking how can we describe and predict what we observe.
Exactly. And this change in thinking is reflected in fields like quantum information theory, where information itself follows the rules of quantum mechanics with all its fuzziness and probability.
So the information itself is playing by these quantum rules.
Yeah.
And we have to learn how to work with it within those rules.
Exactly. And that brings us back to Jörg O. Schneppat's essay. He doesn't just talk about Heisenberg's scientific achievements. He also explores the person behind the science.
Yes. Schneppet gives us a peek at Heisenberg, the human being, his passions, his struggles, his constant curiosity. What was he like outside of all the equations and theories?
Well, he was obviously brilliant, but also a gifted musician, devoted family man, and a nature lover. Schneppat describes someone who found joy and inspiration in both the intellectual world of science and the beauty of the world around him.
It's great to see that even geniuses have lives outside the lab. It makes them seem more human, more relatable.
I agree. And it reminds us that science isn't just about cold facts and equations. It's driven by human curiosity, passion, and a desire to understand the universe and our place in it. Speaking of the universe, Heisenberg's legacy is still shaping how technology is developing today.
Let's talk about that. We touched on quantum computing and quantum communication last time. What's next for these revolutionary technologies?
Quantum computers are still in their early stages, but they have incredible potential. Imagine machines that could break the toughest encryption, revolutionize drug discovery and material science, and make artificial intelligence even more powerful. They could change entire industries.
Wow, that's a lot to take in.
Yeah.
You mentioned quantum computers could threaten cybersecurity, but also offer solutions. Can you explain that?
Sure, a lot of encryption today uses math problems that are hard for regular computers to solve, but a powerful enough quantum computer could crack them easily. That's a big deal for cybersecurity.
So it's like a master key that can open any digital lock.
Exactly, but, like we discussed before, quantum technology itself has a solution: quantum cryptography. It uses the principles of quantum mechanics to make codes that can't be broken.
So it's a quantum arms race. But instead of weapons, we're making better shields to protect our data.
Exactly. And it all goes back to pioneers like Heisenberg. It's amazing how his work, which once seemed so theoretical, is now at the forefront of digital security in the quantum age.
It shows the power of basic research. You never know what amazing applications might come from exploring fundamental questions.
Okay.
Cybersecurity is one thing. What about those other potential uses of quantum computing you mentioned, like drug discovery and material science?
Imagine designing drugs and materials at the atomic level, simulating their properties and how they interact with incredible precision. Quantum computers are perfect for simulating quantum systems, which are incredibly complex and difficult for classical computers.
So instead of trial and error in the lab, scientists could use quantum computers to design and test new drugs and materials virtually.
Exactly. It could speed up the process so much and open up totally new possibilities.
Sounds like science fiction is becoming reality. What about quantum communication? Where are we with that?
Quantum communication is another field with huge potential. Remember, the goal is to make networks that work using quantum mechanics, using quantum entanglement to transmit information securely and maybe even faster than light.
We talked about quantum key distribution, which uses quantum mechanics to make unbreakable codes. But you're talking about something bigger.
Right.
Building an entire quantum internet.
Exactly. Instead of sending bits over wires or through the air, we'd use entangled particles. This could lead to ultra-secure communication channels and maybe even communication faster than light.
Okay. Now my head is really spinning. Faster than light communication. How is that even possible?
It's not about sending signals faster than light itself. It's about using the weirdness of entanglement. When two particles are entangled, they're connected so they share information instantly, no matter how far apart they are.
So it's like two coins that are magically linked. You flip one, and the other flips to the opposite side instantly, even if they're on opposite sides of the world.
Great way to picture it. It's mind-blowing.
Yeah.
But it could revolutionize communication. And of course, it goes back to Werner Heisenberg. He didn't just make discoveries. He opened up entirely new possibilities.
It's clear his legacy goes way beyond specific scientific achievements. He changed how we think about the universe and our place in it.
He did, and we're just starting to explore the vast unknown of the quantum world that he helped us understand.
I'm excited to see what the future holds for quantum technology.
Me too. And that's what we'll be diving into in the next part of our deep dive into Werner Heisenberg.
I can't wait. Back again for the deep dive. We've been exploring Werner Heisenberg and the quantum revolution he started.
Quite a journey, yeah. From his huge scientific contributions to the amazing technology they inspired.
And now the final part of our journey, if I'm remembering right, takes us into philosophy and ethics.
Exactly. We've talked a lot about the exciting potential of quantum technology, but we also need to think about the downsides and the ethical problems it could cause.
Okay, time to get philosophical. What are some of the big ethical worries that Schneppat brings up in his essay?
One of the most urgent is the potential for misuse of these incredibly powerful technologies. We already talked about quantum computers cracking encryption and what that could do to cybersecurity.
It is a little scary to think all our digital security could be so easily broken. What can we do about it?
Schneppat suggests two things. Technologically, We got to develop quantum-resistant encryption, but we also need policies and international agreements to stop people using these technologies for bad stuff.
So it's not just about the tech itself,
Yeah.
but also about how we use it as a society.
Exactly. And it's not just about governments and countries either. Imagine criminals using quantum computers to steal financial data, mess up important infrastructure, even hold whole organizations hostage.
Sounds like total chaos.
It could be, which is why it's so important to start thinking about these problems now before they get even worse. Got to be proactive.
Right. Cybersecurity is huge. What other ethical concerns does Schneeppet mention?
Another one is that quantum technology could make existing social inequalities worse. These technologies will probably be really expensive and need special expertise to use.
So there's a risk that only the rich, big corporations or governments, will benefit from quantum technology.
Yeah, that's a real concern. We have to figure out how to make sure everyone has access to these technologies and how to keep them from making the gap between rich and poor even bigger.
It's like the internet in the early days. There was so much hope about connecting people and spreading information. But we've also seen how it can be used to spread lies and make existing power structures stronger.
Good comparison. We need to learn from that and be really careful about how we develop and use quantum technologies.
Feels like we're on the edge of a new era. Both exciting and a little scary.
I agree. Schneeppet's essay shows that tension between the potential of quantum tech and the responsibility that comes with it.
Okay. Cybersecurity and social equity. Any other ethical dilemmas hiding out there in the quantum world?
Well, the very nature of quantum mechanics brings up deep philosophical questions that have ethical consequences. We talked about the Copenhagen interpretation and how it challenges our usual ideas about reality and the observer.
Right. The idea that reality isn't fixed until we measure it. Does that mean there's no such thing as objective truth?
That's a big one. No easy answer. But it's a question quantum mechanics makes us think about. It challenges our ideas about cause and effect, determinism, even free will.
It's like quantum mechanics is holding up a mirror, making us question the very basics of how we understand ourselves and the universe.
Exhilarating and unsettling at the same time. And it shows how science, philosophy, and ethics are all connected. As we learn more, we inevitably run into profound questions about existence and what our discoveries mean.
So given all this, what can we do what steps can we take to make sure quantum technology is developed and used ethically?
Schneeppet says it starts with open and honest conversation. We need to talk about the potential benefits and risks of quantum technology. And not just scientists and engineers, but policymakers, ethicists, and the general public too.
So it's a societal conversation, not just a scientific one.
Exactly. We need to think about the values we want to follow as we develop and use these powerful technologies. What kind of world do we want to build with quantum computers, quantum communication networks, and quantum sensors?
Like writing a new social contract for the quantum age.
I like that. And that contract needs to deal with justice, equity, accountability, and transparency.
Wow. A lot to consider. But it's also really exciting to be part of this conversation, to help shape the future of this amazing technology.
Absolutely. It's a challenge, but also a privilege to be alive at a time of such huge scientific and technological change.
Well said. Feels like we've just started to see what's possible with quantum technology.
We have. And thanks to pioneers like Werner Heisenberg, who dared to explore the unknown quantum world, we're on a path that could change our world in ways we can't even imagine.
I'm excited to see where it takes us.
Me too.
And on that note, we'll wrap up our deep dive into Werner Heisenberg. It's been an amazing exploration. But the conversation doesn't end here. Keep learning about quantum mechanics. Think about the philosophical questions it asks, and get involved in the important discussions about how we shape our quantum future.
Thanks for joining us on this deep dive.